Hi all. Sometimes people used to complain that condensation will be happening on the building surfaces, means building components. For example, condensation issues on building components, like condensation can come, let's say, on floor it can come, correct. Sometimes on the floor, the condensation issues can come. It can come within air conditioned spaces, and non-air conditioned spaces also it can come. Condensation issues can come on ceiling, false ceiling it can come. And it can come on air terminals, whether there is grills or diffuser, it can come. So what might be the real reason of condensation, and what are the remedies we can mitigate it? So that thing we will be discussing in this session. Okay, so condensation, as I told, the condensation issue can come within air conditioned spaces and in non-air conditioned spaces, unconditioned spaces also it can come. So let me explain. Before going to the topic, I'll be explaining the dew point temperature. What's the concept of dew point temperature? Okay, let me explain that. So let me take a psychrometric chart. So those who have already watched our basic session, you might be already having this idea. See, every state, atmospheric state, will be having a dew point temperature. For example, I'm having like a 36 degrees Celsius of dry bulb temperature and a 60% relative humidity condition. Okay, so this is 31, 32, 33, 34, 35, 36, 10, 20, 30, 40, 50, and this is 60% relative humidity point. On this state, the dew point temperature is, let's say, somewhat it is 25, 26, and 27 degrees Celsius. Means 36 dBT, 60% relative humidity air, you have to cool until 27 degrees Celsius, then only the condensation will start. Means if you want to remove the latent heat within the air, or if you want to do the condensation, if the moisture has to be removed from the air, you have to cool it, right? You have to cool it up to what point? You have to cool it up to dew point temperature, or 100% of relative humidity point, or saturation state. Once the air is saturated, it will not be having any ability to accommodate more water, right? Condensation will happen. So that's why for 36 degrees Celsius dry bulb temperature, 60% relative humidity, when you are cooling this state air up to 27 degrees Celsius, the condensation will start. Like that, every state will be having its own dew point temperature. So dew point temperature is simply nothing. It's a temperature. No, it is recorded by a thermometer. The moisture that is present in the air will start condense. That temperature is called a dew point temperature. For example, a room state 24 degrees Celsius, 50% relative humidity. On that state, as you know, the dew point temperature is 11, 12, nearly 13 degrees Celsius. Correct. Every state will be having a dew point temperature. So whenever the air is cooling less than dew point temperature, the condensation will start. Understood? That's the basics. Now I can come to the point why the condensation is happening within air conditioned spaces. Okay. And there is 4 or 5 reasons are there. The first one, the condensation can come due to high humidity, means due to infiltration it can come. And if duct and all, or condensated drain pipe, everything is having very poor insulation, then also this issue can come. And if the duct components or duct fabrication is not proper, due to the duct leakage, this issue can come. And at the time when you are selecting the equipment, the ADP, apparatus dew point temperature of the cooling coil is too less, or low supply temperature, means from the machine the air is leaving, that off coil temperature, that is called the supply temperature. If low supply temperature, then also it can come. And the next point is short circuiting of air through the air terminals. Due to short circuiting also it can come. The first one, let's say infiltration. See, if you're having a space, surrounding area we will be having atmosphere. Let's say in atmosphere I am having 36 degrees Celsius of dry bulb temperature, 60% relative humidity. on this state, as you know from the psychrometry I have taken, on this state, if the air is cooling up until 27 degrees Celsius, the condensation will start. So dew point temperature of this state is 27 degrees Celsius. And this is my air conditioned space. Okay, the temperature is nearly 24 degrees Celsius. See, so in this scenario, due to infiltration, if the room is not tightly closed, no, it is not tightly sealed, infiltration can come. So whenever a person is going outside, he or she will open the door, or due to the cracks on window or the cracks on door, the cracks on wall, this air will be infiltrating inside. As you know, when this 36 degrees Celsius, 60% relative humidity air is entering inside, the dew point temperature is 27 degrees Celsius, but the room temperature is 24 degrees Celsius. Means the room temperature is 3 degrees Celsius less than the dew point temperature of infiltrated air. So when this air is having contact with the room surface or room air, condensation will happen. Means the moisture that is present in the infiltration air will start condensing, and it will be dripping down, and it will be accumulated on the floor, it will be accumulated on the furniture, sometimes it will be accumulated on the wall surface as well. That's why infiltration is one reason. The second one, poor insulation. For example, if you are having a duct, okay, and if you're having an AC equipment for cooling, okay, from the machine, the supplier temperature is nearly, for example, for 24 degrees Celsius and 50% relative humidity. To achieve the effective condensation, we have to cool the air until 13 degrees Celsius. Then from 13 degrees Celsius, when the air is reaching to 24 degrees Celsius for the same humidity ratio, we will be achieving 50% relative humidity within the spaces. Like that only the system is working. In the basics I have explained. That video is available on YouTube. Okay, so let's say from the machine, the air is leaving at 13 degrees Celsius. So this 13 degrees Celsius of air is traveling through the duct, inside the duct. But outside the duct, we are having unconditioned space only. Let's say this is going above the false ceiling. This duct is going above the false ceiling. Above the false ceiling is an unconditioned space only. We are not having any AC there. Even if we have proposed thermal insulation, and if the thermal insulation is not proper, what will happen? Due to the presence of cold air, the cold air is having contact with the duct surfaces. No, after some time, the metal duct surface temperature will be decreasing. As you know, if the dew point temperature of surrounded air, let's say if it is 24 degrees Celsius, or the dew point temperature of surrounded air is 22 degrees Celsius, but the duct surface temperature is nearly 14 degrees Celsius, example. So when this 22 degrees Celsius of dew point temperature air is having contact with the 14 degrees Celsius, the temperature of duct surface is much lesser than the dew point temperature of surrounded air. So the dews will get accumulated on the duct surface, and this dews will be dripping down. If you are having a false ceiling, if the false ceiling is a plaster of Paris false ceiling, what will happen? Your ceiling may fail, right? That's why not only in the, sometimes if the people are providing 3 meter or 6 meter, whatever it may, with respect to the DB isolation, we have to decide the total length of acoustic lining. Let's say as a standard, if it is 3 meter, and if we are providing 3 meter acoustic insulation inside, after that only we will be providing thermal insulation in some projects to decrease the project cost. And people used to say, anyhow, we are providing acoustic insulation inside, that material will be acting like a thermal insulation. Then why we need to provide an thermal insulation separately in the outside? That's a mistake. For example, as you know, the same issue, this 13 degrees Celsius of air is traveling within the duct system. When this 13 degrees Celsius is having contact with this metal duct on the surface, no, this metal duct, the temperature will be decreasing like 13 or 14. So when the surrounded air is having contact with the duct surface, the dew point temperature of surrounded air is much higher than the surface temperature of this one. So when the air is having contact with this one, dews will get created, condensation will happen. So your ceiling may fail. That's why not only that, suppose if you are having a condensated drain pipe from the fan coil unit or ceiling hung equipment, if you are having a condensated drain pipe, so after the condensation from the cooling coil, the temperature of water that is leaving from through the condensated drain pipe is somewhat near to 13 degrees Celsius only. So if the condensated drain pipe, if you have not provided a sufficient thermal insulation, what will happen when the surrounded air is having contact with this thermal insulation, means a condensate drain pipe, condensation can come on the surface of condensate drain pipe. If you are having a refrigerant liquid line or vapor line, means normally it will be happening through the vapor line. So the refrigerant vapor line, chilled water supply and return line, the pure thermal insulation, if you are having within the building, everywhere we can have this condensation issue. So poor insulation is a reason of condensation. Duct leakage can come. Duct leakage, for example, Let's say I'm having a space and this is my false ceiling. Above I am having a duct. Okay, so above this false ceiling, I'm having air with, let's say, example like 36 degrees Celsius and 60% relative. It might be much lesser than that. For example, 36 degrees Celsius and 60% relative humidity air we are having above false ceiling, and it is having a dew point temperature of 27 degrees Celsius. Fine. So if the duct is not properly fabricated, through the duct and all, the air will be leaking outside. Correct. So this is cold air only. It is having a temperature of 13 or 14 degrees Celsius. So when this 14 degrees Celsius of air is having with the ceiling air, means unconditioned air that we are having above the false ceiling, when it is having contact, no, the condensation can come. Because the dew point temperature of this is 27 degrees Celsius above the false ceiling, and the air that is coming out as a leakage from the duct is having 14 degrees Celsius. So when this 36 degrees, 60% air is touching 14 degree, the dew point temperature is 27, but the temperature of air that is leaking is 14. Definitely condensation can come there. So water will be accumulated on the ceiling. Ceiling may fail. That's why poor insulation is the reason of what this one, no, which one, condensation. Even duct leakage is same. Duct leakage is air leakage only. Okay. Now low supply temperature also can come an issue. Low supply temperature, for example, let me clear it. See, anyhow, if you're having a false ceiling, okay, and this is a diffuser, the temperature of air that is coming out from the AC equipment, let's say normally that might be 13 or 14 degrees Celsius. Accordingly, we have designed it. But in hot and humid time, sometimes if the infiltration is high, okay, and if the supply temperature is anyhow, when due to the infiltration, even if that is 13 degrees Celsius or 14, condensation can come, but infiltration we have to neglect. Correct. But low supply temperature is also a reason of condensation, because instead of 13, sometimes the supply temperature is 10 degrees Celsius or 9 degrees Celsius and all. The surrounded air with the dew point temperature much lesser than the supply temperature, when it is having contact with this air, condensation can come. Even if that is a perfectly sealed building, whenever there is very limited infiltration, then in that scenario also, if the low supply temperature through the diffuser can come, or from the machine can come, it can result of for this one, which one, condensation issues. Okay. Now the next one is short circuiting. Short circuiting. What is short circuiting? If this one, no, the supply air is not effectively distributing through the spaces, no, that is called short circuiting. For example, as you know, whenever it is possible, we have to maintain the return air terminal velocity slightly less than the supply terminal. For example, I'm having a supply air diffuser and I'm having a return air diffuser as well. And the delivery velocity through the supply diffuser is, let's say, like a 2.5 meter per second. And the suction velocity through the return diffuser, let's say if it is 3 meter per second, what will happen? The suction velocity is slightly high. When the diffuser is delivering the air, since comparing to the supply velocity, the return velocity is high. Instead of coming to the spaces, the return diffuser will be sucking it. So the air will not be reaching to the spaces. Correct. So what will happen? Return, most of the time, the supply might be closed with the duct system. Return might be open only, no, because if the machine is exactly located above the false ceiling or the space it is serving, return duct is not mandatory always. So in that scenario, what will happen? No, the return duct will be open only, not return diffuser will be open only, no duct will be connected there. But normally, the temperature of air that is coming as a return is somewhat near to the room temperature only. We will be assuming like that. 1 or 2 degrees Celsius difference can come. It should come like nearly 24 or 26 degrees Celsius. But due to the short circuiting, or if the return diffuser velocity is slightly higher than the supply, so this cold air will be touching the return diffuser, then the return diffuser surface temperature will be decreasing. So when in that scenario, when the room temperature or the room air is touching on the return diffuser, what will happen? Condensation can come. Okay, this is called a short circuit. This is also an issue. And also, if the supply diffuser velocity is too high or the throw is very less. What is throw? If you're considering an air terminal, how much horizontal distance the diffuser is traveling, that is called a throw. If the throw is very poor, sometimes directly the air will be coming down. It will not be effectively touching all the spaces. No, air distribution might be proper. So if the air distribution is not proper, if the throw selection is not proper, sometimes no cold pocket will get generated on surfaces on the inside the spaces. No, in that scenario also, when hot air is having contact with that cold regions, condensation can come. But this low supply temperature, short circuiting is negligible reason only. The major reason of condensation within the air conditioned spaces are these first three only: infiltration, poor insulation, and duct leakage. Low supply temperature also can come because on the surface of air terminals, if the condensation is happening, the major reason is on is low supply temperature only. Okay, these are the reason of condensation within air conditioned spaces. In non-air conditioned spaces also it can come. Unconditioned spaces, this issue can come. Then the real first reason might be contact with the like cold surfaces only. The second one, due to like night cooling also this issue can come. Okay, for example, I'm having two spaces and one space is like a air conditioned spaces and the other one is non-air conditioned spaces only. Let's say for example, it is open to atmosphere or whatever it may, like just for like a class purpose, I'll be considering the temperature within the space is 36 degrees Celsius dry bulb temperature and 60% relative humidity. On that state, dew point temperature is 27 degrees Celsius. Okay. See, since this room is having AC, we might be using a temperature of 24 degrees Celsius. And this is a partition wall. So this partition wall is exposing to the building surface. So if the partition wall is not a thermally perfectly insulated wall, what will happen? The surface terminal, heat will, due to the conduction, the heat will be transferring to the other side. So eventually the other side also, the temperature will be reaching to somewhat near to 24 degrees Celsius. Correct? So when the inside air is having a dew point temperature of 27 degrees Celsius, but due to the presence of nearest air conditioned spaces, due to conduction, this wall is having now a temperature of 24. So now this hot air is having contact with these cold surfaces. What will happen? Condensation can come. Condensation can come. Correct? And nighttime also this issue can come. Nighttime, for example, it is an unconditioned spaces. I am having a window there, no window, and inside and outside. With respect, condensation can come inside and outside. Normally for air conditioned spaces, it will be happening outside because if you're having a glass window, correct. For an air conditioned space, okay, I'm having an AC room. It is a glass window. Okay, inside I might be having 24 degrees Celsius, but atmosphere is having a dew point temperature of 27 degrees. That's atmosphere is having 36 degrees Celsius and 60% RH. On that state, dew point temperature is 27. But inside the room, I am having 24. Outside, it is 27. So when the atmosphere is having contact with the building glass and all, the glass surface temperature is somewhat near to 24 only. No, what will happen? Condensation issue can come. Means, but that will happen to the outside. Same in the car, we will be having issue. That's why in the car backside and front side, we will be having heating element. Backside, we will be having like a what defogger resistance coil will be there. That will be heating the glasses. Accordingly, the glass surface temperature will be increasing so that the condensation issue we can avoid. Means if the surface temperature of glass is increasing above the dew point temperature of atmosphere, no more condensation will happen. No. So that's why. So normally air conditioned spaces, condensation in the summertime, most of the time will be happening in the outside glasses. But for non-air conditioned spaces, suppose it is non-AC space, condensation sometimes can come inside. For example, if my atmospheric temperature is, let's say atmospheric temperature is 24, my room, if I am not having, if the room, let's say room temperature is like 36 degrees Celsius and is 60% relative humidity, the dew point temperature of the room is 27 degrees Celsius. It is unconditioned space. But in the nighttime, the atmosphere cools, right? So in that scenario, let's say if you're having a glass and building surfaces, the glass temperature will reach near to 24. But the room dew point is 27. So when this 27 degrees Celsius or 36 means room air is having contact with this glass surfaces, condensation can come. That is called a night cooling. Okay, so that's why how we can avoid it. For example, non-AC spaces, condensation issue is negligible only. Not only that, sometimes no, if you're having an AC there, just opposite to the AC, if you're having a window, and if the AC cold air is having a 13 degrees Celsius, when it is continuously touching this window, the atmosphere, this one atmospheric air is having a contact with it. So in that scenario, the glass surface temperature is not 24 degrees Celsius as per the room. Due to the 13 degrees Celsius is directly hitting on the glass surface temperature will be drastically decreasing near to 13. So excess condensation can come in this scenario and all. Okay, so if you are providing a curtain there up to a certain extent, you can avoid it. So in this scenario, like with contact with the cold surfaces, if you are proposing a thermal insulation within the spaces, then this condensation issue we can avoid. Okay, so this if you are providing means if the infiltration, if you are neglecting, avoid infiltration, tightly seal everything, condensation issue we can avoid up to a certain extent. And then insulation, whether that is condensate drain pipe, duct, refrigerant pipes, like what this one now, chilled water pipes, thermal insulation should be proper. Ductive fabrication should be proper. Air leakage has to be avoided. The supply temperature through the diffuser has to be perfect. Low supply temperature also can enhance this condensation issue. Diffuser selection should be proper. Return air velocity should be minimum, less than the supply, or somewhat equal to supply also fine. It should not be return air velocity should not higher than supply. Short circuiting has to be avoided. Air distribution should be proper. If you are doing all these things up to a certain extent, we can avoid. No, 99% we can avoid this condensation issue. Okay, most of the time people will be complaining. Suppose if you are having a toilet area and if you are having another air conditioned area, people are always complaining near to the door area we are having. Suppose if you are having a door, people will be entering from the toilet area to inside. Okay, near, so we are having a partition in between toilet and the air conditioned space. Here we will be on the that partition area we will be having what condensation issue. The reason is this one only, due to the infiltration from toilet is not air conditioned space. No, toilet is not an air conditioned space, but if the toilet is properly negatively air conditioned area, means negatively pressurized area, this issue will not come because cold air will be continuously moving to the toilet, hot air will not come outside. Okay, but if the toilet exhaust system is not properly working, if the toilet is a positively pressurized space, the hot air from the toilet area will be coming outside. So the dew point temperature of this hot air is much higher than the room air temperature only. Let's say the dew point temperature of toilet air is 27 degrees Celsius, but the room temperature air is somewhat near to 24 degrees Celsius. When this air is having contact with the cold air, condensation issue can come. Okay, all this reason is somewhat infiltration is a real reason. Then ducted, poor insulation, all these things. Okay. Hope it is clear. I guess most of lot of students, like experienced people, were also asking the same doubt lot of time. That's why I thought I can make a video for that. Hope this video is helpful for you. Okay, thank you everyone.